In this video we're going to explore how to add tolerances to drawings in Fusion, and we're going to do that by utilizing activity 211 called Tolerate This. So on number 21 we have a list of tolerances we're going to add to some dimensions, and we're going to start off with letter A, which says that we're going to add a bilateral tolerance or a symmetric tolerance as noted in Fusion of 0.10 inches for the overall length, width, and depth. So I'm going to zoom in for the height of 2. Double left clicking on the dimension will bring up the edit dimension dialog box, and I can go ahead and check the tolerances box. We do want a symmetrical tolerance, and I want to go ahead and set that to be 0.1. Notice that we don't have any zeros showing up, so I am going to go through and click on the trailing zeros option to be able to show those. So that way we're seeing the correct level of precision. So I'm going to repeat that same process now for the overall height of our block. Again, just making sure we have the right tolerance value, and we check our trailing zeros. And then I'll go ahead and set the same thing for the width. So that will take care of letter A, and now we can go through and look at moving on to letter B, which says we're going to stack limit dimensions to locate the holes along the depth dimension, and in parentheses they have the 0.5 dimension, so they're talking about this one right here. And so that the dimension can vary between the dimension given above and be 0.03 inches larger. So Fusion kind of does a lot of the work for you. So I'm going to check tolerances. We're going to go ahead and we want to stack limit dimensions. So here we have limits under the type. And here they talk about the upper tolerance. Well, if you look, 0.01, it's adding it to 0.5. So actually the lower tolerance, we don't want to have anything added to that value. So we want 0.5. And then we're going to add 0.03. So just like as it's noted on the activity. And then I'm going to go ahead and turn on the trailing zero, so that way we're able to see that 0.5 measurement. So that allows us to see that we can have a little bit of variation of where those hole locations will be. Alright, that takes care of letter B. Letter C says in order to better control the hole locations, we want to use datum dimensioning, or also known as baseline dimensioning, for the dimensions along the long dimension of 6 inches. Note the datum location is shown in the drawing above. So what they mean here is that we are going to, I'm going to go ahead and drag this down a little bit more. We're going to need a little bit more room, and we already have a 0.5 measurement, so I'm going to go ahead and get rid of the rest of these 1-inch dimensions, and I'm going to go ahead and go to dimensions, and I'm going to choose baseline dimension. So it says to select the base dimension, so I'm going to go ahead and I'm going to select the 0.5, and if you notice, it's going to pick up the first extension line on the left side, and then all I got to do is I just got to click the centers of the holes. So once I do that, it'll set a new dimension in. So I'm going to keep going down and keep adding until I have all the centers of the holes located, and I can right click and say OK. And then again, we may need to make a little bit more room on this drawing, so I'm going to drag the view label down, drag the section view down a little bit, and I may have to bring the label up just a small amount. And then I can go ahead and bring down the dimensions. So this is known as baseline or datum style dimensioning, where they all are referencing off of a reference edge. And so this first edge right here on the left side is going to be what they reference. So that takes care of a lot of our tolerancing issues, a lot of times to do some datum dimensioning. Alright, letter D says a unilateral or a deviation tolerance of 0.003 of an inch greater for the counterbore diameter on the 0.38 through hole. So it says we want to change the precision and everything there for to show 3 digits to the right of the decimal place. So the counterbore diameter, when I double click on it, so we want to go through and make sure our cursor gets set after 0.638, and with this one here we're actually going to go through and kind of add in, they say we want a bilateral tolerance. So with hole notes we don't necessarily have we don't necessarily have an option for tolerances, but we're going to be able to put in a tolerance to be able to do that. So a bilateral tolerance, we're going to add in a plus minus, and here we can go through and we can type in a 0.003 to go through and to kind of make that look a little bit better. I'll put a little space in there Put a space in there as well. So when I click off of that, now we have our tolerance, and I may need to make some adjustments to some of the hole notes so that way we can read them clearly and no lines are crossing, things like that. And that takes care of letter D. Now we have a bilateral symmetric tolerance of 2/1000 of an inch, and we're going to put it on the 3/8 countersink through hole. So on this one here, they want it on the diameter of that countersunk hole. So, and again, another bilateral tolerance, so I double left click in there. I can go through and I can place my cursor, spacebar, add my symbol, 0.00, and then start typing in 0.002, and that will go through and finish out our drawing. So those are methods to go through and how to add tolerances to specific dimensions on a drawing. The last thing we need to do is add a general tolerances table to the drawing. I'm going to do that by going under tables and choosing custom table. Now usually what I like to do is I like to snap the corner right above on the title block down here toward the bottom. I'm going to change the table direction to go down, and then some things that we may want to take a look at are I'm just going to left click off of here, and then as I click on like the column, you'll see how it'll highlight in kind of a yellowish orange color. I'm going to go ahead and I'm going to delete the selected column, and I'm going to go ahead and delete it there from the menu, and I'll go ahead and hit close. Now this table is going to be ready for input, but I'm going to go ahead and move it. So I'm going to grab the move command, I'm going to select the table, and then it wants me to grab what point. So I'm going to click on the point to point option, grab the bottom right hand corner, and I'm going to move it, go ahead and put it down here in the bottom right hand corner right above the title block, and I can say OK. Now from here in the very first one I should have a merged two cells together, so I'm going to go ahead and put in here, this is the general tolerances in all caps, and then underneath here I can put linear dimensions, and then on this side I can go through and I can put angles. Now again, what might happen is as you try to go through and move this, the table may move down, so it might be one of those things. Use the move command. If it starts to move on you, I can transform. I'm going to grab it by the upper corner, and let's go ahead and I'll set it up here for now until we get all the text in. But I should have 3 rows below linear dimensions, and this way I can go through and type in x point x, and then utilizing the symbols I can go through and do plus or minus 0.02 or 20/1000 of an inch. And I'm just going to continue to repeat this process by adding in the symbols and typing in what information that I need into the table. And this will go through and give me my general tolerances table. So if I need to go through and lengthen this out, usually I like to go through and give linear dimensions all one line, but I'm going to go ahead and move, select the table, transform, grab that bottom right corner. Now that I got the table finalized, get it placed. There's my general tolerances table, and this will finalize the drawing for activity 211. Tolerate this.